basically, we have two pillars today. One pillar, as you know, we have a very sad loss a few months ago. Dear John Mustafa passed away. And of course, when we organize an event, and we cannot skip this part, he was a very important figure for mining engineering program. He served as a mentor, lecturer, and alumni. You know, he was an unforgettable person in our history. And at least 10-15 minutes, we would like to talk about him. And I see the Masha family also here. Probably they have something to tell us. But the first part, I think maybe we can start with our department chair, and Professor Richard Kromick started his tenure in last June. And Richard, Richard, would you?
I'm here, Mustafa.
Yeah, let me. Yeah, okay. And could you say something about this event and mining program?
Sure. I guess the person that's chatting just muted. Okay. So welcome everybody. It's my pleasure to welcome you to this event. I lament the same way that Professor Hassani and Professor Kumral did that we can't be in person. I'd like to thank everybody that's here as an alumni, all the students, the panelists, the Mossop family for showing up. And even though we're not here and able to do this in person, it's really good to see a lot of people here attending. I'm Richard Kromick. I'm the new chair of the Department of Mining and Materials Engineering. And I'm really excited for this 150-year celebration for the mining program. It's a great achievement. It's also an opportunity for me to think about the next 150 years and all of the professors in the mining section to think about what the future holds. And I think the theme of the panel that you'll have this evening is going to be really interesting in a discussion to address that. So I can't give any personal stories about people in mining. So instead, what I did to prepare for this was I kind of thought about 150 years and what that really means for us on the planet, doing mining, doing various technological things. So I looked up various milestones in the history of our planet. So turns out the age of the Earth is estimated to be 4.5 billion years by scientists. So that's about 30 million times longer than the 150 years for the mining program. The extinction of dinosaurs 65 million years ago is the estimate. That's 433,000 times longer than 150 years. Homo sapiens on planet Earth is estimated to be 300,000 years. That's 2,000 times longer than we've had the mining program. These are all from Google, by the way, so if they're completely wrong, don't blame me. First recorded use of bronze, 3,500 BC. That's about 37 times longer that we've been using bronze. First recorded use of steel is 1800 BC. That's approximately 25 times longer than the 150 years. And according to Google, the first mine in Canada that was considered to be an industrial scale mine was 1738. And that's only about a little less than twice as long as the mining program. So these comparisons may make it seem like 150 years is really nothing, but when you think about our lifespans and how we accomplish things as human beings, 150 years is actually quite a big accomplishment. And I think it also reminds us how progress for us as a species is made almost entirely by educating the next generation. It's a mission that's carried out largely by universities, but more accurately by real people, professors, teaching assistants, support staff that enable us to educate the next generation. As many of you know, we're honoring John Mossop tonight, and I wanted to make you aware that there's a fund in his name that's been created that will support students through scholarships. So if we think about the next 150 years of mining, We hope that we'll have that fund available, named scholarship, going forward for the next 150 years or more. And last thing, because I know I'm taking up too much time, is the topic of the panel, innovation and sustainability. I think this is a really appropriate topic, as we need to start thinking about what the next 150 years will actually look like. There's a lot of talk about space mining, sustainability, entirely new ways of mining as natural resources are becoming harder to find or coming from different or more complicated sources. And I think the better job we do in foreseeing what the next 150 years should look like, the better job us as university professors will do in training the next generations of engineers and mining engineers. So I'm happy to see that we're recording this because I actually have to commute home right now, so I won't be able to stay for the panel, but I'm really looking forward to listening to the recording, and I will stick around for a few minutes before I have to depart. So again, welcome and thank you all for being here this evening, and I'll hand it back to Professor Kumral.
Thank you, Richard. Okay, we are going to spend about 15-20 minutes before panel. But I have a little surprise for you. I would like to share a picture with you. Are you able to see this picture? Let me share it.
Yeah, we see
okay,
it.
This is okay. It's a photo from a graduation photo from 1957. As you see, let me enlarge. And as you see here, and this young man, Claire Marchand, he's with us today. He's graduated from 1957. And hello, Mr. Marchand, how are you? Yeah, it's great honor to see you today, and I hope you health, safety, wellness. And could you say something to us today?
You telling me I can talk to you?
Yeah.
Yes.
Yeah.
Yes, that's your turn, Mr. Marchand.
First of all, it's about 64 years since I graduated, so that's quite a long time. And I still think very fondly of McGill, especially this time of the year, because one of my favorite memories is going up in the mountain and mapping the strata with the geology department. And of course, there's the football games and the frat house parties and all those things. That's all gone, but they're good memories. In graduation, I went to Noranda with Reg McLaughlin, who at one time or another was a professor at McGill. He's gone now, but he was a very good friend. Well, about 10 years, Noranda and Normetal, and then I left. I went in with consultants for a year or so, and then I tied in with a construction contracting firm called the Harrison Group, and I spent the rest of my life doing that, right up until I retired around 2002. Over that period of time, I think I've touched just about almost, this is never ever everything, but many facets of mining, both in base metal, precious metals, and other products like, asbestos and cement and so on. So I'm very happy to say hello to all you people, except for the little guy, the guy with the white beard. I'm probably older than any one of you. So that's about all I've got to say.
Okay, thank you very much, Mr. Marchand. Yeah, and
Mr. Marchand, this is Ferry Hassani. I just wanted to tell you that the wife of Mr. McLaughlin still is active in Montreal, and she's the head of the Women Association, Mining Association, Montreal branch, and she raises funds for our students' scholarship. So,
oh, that's nice. I know
yeah,
her.
yeah, Pat, yes.
Yeah, yeah.
Yeah, I will tell her that we met you at least remotely anyway.
Or you tell her hello for me.
Okay, I will do that.
And I really appreciate that. I remember her quite well.
Excellent, excellent.
Sad when Reggie went off on me, you know.
That's right.
We were good friends. Anyhow,
Excellent.
that's that much.
Thank you very much, Mr. Marchand. And please stay touched with us, and I hope we will meet in person soon.
Okay.
Yeah, take care. Yeah. Let's go more forward. And then in this section, I think before I start the late John Moshop piece, guys, maybe some of you join here for just a panel. But as I said in the beginning, and John Moshop is very important figure for us, and we couldn't miss this opportunity to commemorate him. And Moshop family, as I said here, but I would like to show a picture of him as I believe he's a very young and handsome boy here. I believe it should be from late 50s. Maybe Mr. Marchand already know him, I don't know. As a cute boy, as you see, and unfortunately he passed away a few months ago. And Moshop family here, I would like to start with them, Colleen, Michelle, and Barbara. Would you like to say something to us?
Okay, I'll start. My brother Michael and I thank you for the opportunity to say a few words about Dad, and Colleen, Dad's wife, is here, and our family is really deeply honored that a group of students felt strongly enough about Dad to start a scholarship in his name. This is absolutely tremendous. So I'm just going to share a couple thoughts and then pass it on to Michael. Like this week, mining has been in the news with the incident in Sudbury and the miners stuck underground and having to climb out and stuff like that. And, I just wish Dad was here because we'd be on the phone talking about it. Dad has stories. I don't know if any of you who here had Dad as the professor, but I know there are a few of you. And he had tons of stories because he worked in the mines before he got into consulting. And then when he retired, that's when he became a lecturer at McGill. So this year is my homecoming year. And I studied mining engineering because of Dad. I wanted to go into geophysics and study volcanoes of all things. But Dad said, oh, there's a geophysics program with the mining engineering program. You take that and at least get to be an engineer. And so I did that, and I was having a hard time getting a job in the summer. And he says, well, why don't you apply at the Kilmar mine, which is halfway between Ottawa and Montreal. And his friend was the mine manager. And he said he didn't get me the job, but I know he did. And so after that first summer, I was hooked and I stayed in mining and had a great career, and I'm retired. And so we're going to hear that there's lots of stories about Dad helping people get into mining and get enthusiastic about mining. And I believe that's why we're here and having the commemoration. So Michael has a few things to say, and so I'll pass it on to Michael now.
If I could unmute myself. Or double muted, I'm not sure you guys have that problem too. No, thank you very much for inviting me and reaching out. As Barbara said, I think I I could say like I bonded through my dad through actually starting my first semester at McGill in mining engineering. I decided to jump ship into mechanical engineering. He forgave me for that jump, but it opened my eyes how much my dad contributed and how much he loved his time at McGill. It was a great way to dovetail his career by sharing his knowledge of, as Barbara's mentioned, of his hands-on experience. And the fact that also he was like one of those teachers for the students, as I have fond memories of my dad, you know, watching us playing broomball or, you know, a flag football with Nigel and the gang and Mike Kaza. Also having people over for like during graduation, like he'll have students over with my mom in the backyard. And my fondest memory is, you know, when you have there was the engineer carnival, you know, there was a scavenger hunt. He was only the one of the bravest professors to put on a Speedo to have a photo of him in a Speedo just to so that the students could win the scavenger hunt. But the thing is, I said, like, what helps me, like, you know, go through this is, you know, how like his legacy will pass on with his family and his students, as well as his students as well. I just like to share that. So I moved into the mining and the aerospace industry. Even in the aerospace industry, my dad has touched people there. I'll have random phone calls, some people in Bombardier, and they would say, by chance, are you the son of John Mossop? And by chance, they took a elective in intro mining, and how much they expressed their joys and how much their gratitude, how much they learned taking this course. So it's not just the mining community, but it's the overall engineering community that my dad did touch a lot of people's lives. So so thank you very much for everybody to initiate this fund. Thank you for the people who came to the funeral. As I said, I think my dad would have been very pleased of the amount of support that that everybody's shown to us as a family and sharing these great stories. So thanks again.
Yeah, thank you, Michael. Pauline, would you like to say a few words? You're mute, I guess. You're mute. We are not able to hear you. You are mute.
Okay.
Yeah, that's okay. Yeah, you can.
Colleen, you're still muted.
You're still mute.
Is the host able to unmute her?
Yes. Okay. Yeah, you can talk
okay.
now. Yeah.
She's unmuted.
Yeah.
Can you hear me now?
Yes, we can hear. Yes.
Yeah. I just want to say that John was very proud of these students. He taught the world of them, and he would be over the moon today if he see this happening. And thank you for everything. Thank you.
Thank you, Colin. Just a little parenthesis I have. I was told yesterday. I think Barbara was one of the first mining engineer in Canada. Female mining engineers, I'm sorry. And this is another accomplishment of Mossop family, I think.
Oh, I think I was around the sixth. Justina Laureline, I think was one of the first, but when I started, the year I started, the first 2 women graduated from the mining program. So I wasn't the first.
Was it from McGill?
Yes.
Barbara?
Yes. Yeah, I graduated from McGill, and Justina and I can't remember the other person, but they graduated from McGill. And then there's a few other, every year there was between that time and my year, there was a couple girls. So I think I was around the 6th.
Yeah. I believe you're 1978, correct?
No, I started in 78, and the first that's when the first graduated.
Okay.
Graduated in 1981.
Okay.
Yeah. Yeah.
Top 10.
Thank you.
Yeah.
Thank you, Barbara. Another topic I would like to mention today in the honor of John Mossop and the MAPTEC. is a software company, mine planning and mine design software company. And they intended to donate a LiDAR scanner to us, and their donation still in progress. Hopefully it will be completed soon, and they will organize another in-person activity. And I just want to let you know, and still, I mean, some of our graduates still thinking in different way, and they donate this, and that will be great device for us. I believe it will be contribute to our education quality. And thank you very much, Maptech and Rodrigo. Would you like to say a few words?
Yeah, of course, and I'll be super quick because I think it's an underserved space to talk in front of everybody and talk about Professor Mossop's legacy. But I guess the relationship with Maptech, between Maptech and McGill goes a few years back, probably 10, 15 years. I think it got a lot more, a lot closer and a lot more personal since we opened the office here. And we do have a couple of alumni working with us. So when Professor Mossop passed, it was Delphine's idea to donate the scanner, not just to honor his legacy, but also to continue that legacy and putting some of the technology we do in hands of the students that at the end of the day, it's products and technology they're going to be using in the real world. So that's it on my end. We're very happy to be a very, 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 very small part of this event.
Yeah. Thank you very much, Rodrigo.
I don't know, Delph, maybe you have a more personal insight into this that you might want to add to it.
Yeah, I think a lot of us was inspired by John Mossop becoming mining engineers, and by his passion and the way he taught us about mining in general. And I think that tool, the laser scanners, it's used at mining industry, will be a good tool to teach students to use and be exposed to new technologies. Yeah. So really in his memory and honor.
Yeah, thank you, Delphine. And I think we have a little session for John Mossop part and for students prepare Nigel, Vincent, as I remember, Michael, and I think we are getting a bit late on our panel. And would you like to say something, Nigel?
Yeah, I think Mike's going to go first for a minute, then Vincent for a minute or two, and then I'm going to speak for a minute and then see if anyone else wants to add a few comments. So go ahead, Michael Kaza Esquire.
Thanks, everyone. So wonderful to see former classmates that I haven't seen in a while, to see Michael and Pauline. As you know, John was very much a part of our lives when we were at McGill, and Michael and Pauline were also there with us. Like Michael said, we played a lot of flag ball and broom ball, and we're very close knit. We spent a lot of time with John and Pauline and Michael as well, and in the after hours, you know, Friday nights in Indiana's were very much, you know, part of our education at McGill. And, you know, John really, you know, certainly an influence on my life, and it's abundantly clear from the responses that we've received from a number of students on social media, former students, that he's had the same influence on other people. It's very much a fabric of part of who I am today. He taught us, you know, the importance of finding a balance in life between work, school, relationships, and even, you know, our own personal endeavors. We had a lot of discussions about his running and that sort of thing. And I certainly remember the picture of him and Pauline biking down St. Catharines during the ice storm on his way to work. John was very passionate, and he instilled that passion in students. And even though I'm a lawyer, I still carry that passion of mining. You know, I truly believe that mining is probably one of the most important endeavors in engineering. The people are great. There's always an adventure. I absolutely still love mining and keep in touch with you know, people I've worked with and went to school with. You know, John, you know, personified what I thought a mining engineer should be. He was adventurous, he was curious, he was practical. He always encouraged us to develop relationships with students from different years. Like we were all one big family, and I think John was certainly a part of that. Relationships with his colleagues, people in industry. You know, he was always a presence. He was always there for us. You know, for those of us who weren't from Thunder Bay, or sorry, from Montreal, you know, we spent a lot of time with John, and you know, it was appreciated, right? That's kind of a home away from home for us, and certainly appreciate that. And I'm glad I could be part of, you know, carrying on his legacy. You know, he's still in the conversation in my house. My children know who John Mossop is, and I just tell them the wonderful stories and experiences that I've had. You know, a big part of John was a big part of all that. So, you know, wonderful initiative that we've taken on to continue his legacy. And you know, I think, like I said before, I think that you know, someone who receives a scholarship should, one of the prerequisites should be that they bike through the winter like John did. So I don't know if that's going to stick, but that's my pitch. And again, nice to see everyone, and thanks for letting me tell you what John Mossop meant.
Thank you.
Thanks, Mike. Vincent Martin.
Hi everyone. It's a real. I'm really happy to be here tonight, and also have the opportunity to share a few memories about John and my time at McGill in mining engineering. Well, first of all, I wanted to offer my condolences. Sorry, hard word for me. To Colleen, Barbara, and Michael. I mean. I'm as you've seen in the last few months, it's been obvious since John's passing how much he was loved and admired by many of us. As for me, I mean, he's the one who made me discover the field of mining engineering at the open house when I was in CEGEP, so that was a few years ago, and also through the introduction to mining class that we took during our first semester. And I remember all the anecdotes and how it opened up this new world that I knew nothing about. I'm from the South Shore of Montreal, so not many mines there. And all of a sudden you discover this world that offers you great opportunities, that offers you the chance to meet wonderful people, to travel. And I mean, it's been great since. And I was trying to remember two things about John, and two things popped up. And I'm sure you guys will all thought about his great generosity. Obviously, Mike alluded to the Friday nights, where John was very generous with his students, but also I find very generous of his time also. Whether we were an actual student or an old student, I remember when I was struggling through grad school, talking to John when I would go downtown to McGill, and he was always happy to offer advice, to listen, and always happy to see us. And the other thing that always struck me with John is that whoever you are, whoever you were, he treated everybody the same way. And I thought that was incredible, and something that I try to do as an adult and also to teach to my children. And I remember Friday nights at Indiana's, whether you were a businessman or a U1 or a friend of a friend of a friend that showed up at 8 p.m., he showed the same interest and the same desire to learn from people. And he was just happy to be with people and to be surrounded with people to discuss. And I think that's what I remember the most about him. So I guess I could go on, those who know me, for many more minutes, but I'll keep it short. So it's been really an honor to be one of his students, and
Nigel,
to share a few memories with him, with you tonight, and to see you all tonight. So
okay,
have a nice evening.
Nigel,
Yes.
you know what I am thinking? I think the people has a lot of words to say about John Mossop. Let's start with panel right now. Then after panel, I will be happy to stay here. Then we can chat as you wish. You know, we don't have time limitation. Maybe we can go for panel because some people attended here for just panel. You know, maybe we
Absolutely.
should. Yeah, but
Thanks, Mike. Thanks, Vincent. And,
yeah, thank you.
Yeah,
Please
if there's
stay
time at
with
the
us,
very
you know.
end,
Yeah, after
Time
that,
at the
you
end,
know,
I'll raise a beer to John.
yes, after panel, you know, we will continue. We
Very
will
good.
have no time limitation. We can continue. Let's move on
Excellent.
the panel now. And as you see in the schedule, we have a panel entitled Towards the Future of Mining Engineering, Innovation and Sustainability. And moderator is Jeff Cassoff. He's also one of our graduates. Jeff?
Yeah, thank you, Professor Kumral. I was going to say a few words about John as well, but again, I'll save those to the end. But I am putting the a link to the scholarship website in the chat. So our goal was $100,000, and we've already raised $62,000. So I put a link in the chat, and then yeah, at the end of this, we'll get back and we can talk lots more about John. I know Mitch, one of our panelists, has a 7 o'clock hard stop. He has to leave at 7, so I want to make sure we're careful with the timing there as well. So let's get on to the panel. So what I'm going to do is I'm going to be asking questions to our panelists, and hopefully we'll have some time at the end where we can open the floor to questions from our audience. So put questions in the chat, and then we'll get to those after if we have time. So let me introduce the panelists. So we've assembled a great panel with a wide range of experience who are currently located right across North America and who have graduated in 3 different decades. Before I introduce our wonderful panelists, let me introduce myself. So Jeff Cassoff, born and raised in Montreal, graduated from McGill Mining Engineering in 1999. After a brief stint with Kiewit Construction in Connecticut, I moved to Fort McMurray to join Syncrude, where I had completed my 2 previous work terms. I spent 6 years at Syncrude working in the North Mine and then at Aurora, before moving from Fort McMurray to Calgary, which is when I started my career in consulting with Norwest Corporation, which is now part of the Stantec Group. After 3 years in Calgary, I moved back to Montreal and spent 8 years with the consulting company Metchem, which is now part of the DRA Group. In 2016, I joined BBA, and my current role is team leader for mining engineering at our Montreal office. I'm also a partner with the company. My experience is in open pit mining, and I've worked on many projects in Quebec and Canada, as well as several international projects in the US, Morocco, Mauritania, Guinea, Suriname, Guyana, Argentina, and I'm currently working on a project in Mexico. I've worked with many commodities, including iron ore, gold, silver, titanium, bauxite, lithium, graphite, and I'll be working on a rare earths project as well in the coming months. And since 2019, I've been the chair of the Montreal branch of the CIM. So now let's meet our panelists. We'll start with Laura Mottola. Laura is actually standing in for Angelina Mehta, who, as I understand, is on a plane as we speak. So I guess that's a pretty good excuse for not being here with us. But Angelina says she'll be joining the webcast as soon as she lands. And Angelina was instrumental in organizing this event, so I'd like to thank her for her effort. Similar to Angelina, Laura has been a huge role model for female engineers. In 2018, she co-founded the Artemis Project, which is a social enterprise founded on a collective of female entrepreneurs focused on disruptive change in global economic, environmental, and social development in mining. Artemis Project drives agile and innovative business outcomes between female entrepreneurs and mining companies seeking to transition from ESG compliance to using ESG as an imperative for genuine change, improve business performance, resulting in an improved world. Laura was born and raised in Italy. She immigrated to Canada with her parents from Milan when she was a teenager. Living in Montreal, Laura graduated from McGill Mining Engineering in 1992 and also completed a master's degree in mining automation at McGill in 1996. Laura began her career as an automation specialist working at the General Motors Oshawa car assembly plant. She then worked in Sudbury with Inco, now Vale, during the height of Canadian underground teleoperation and automation years. She's had many different roles in both consulting and for mining operations in the Americas and Australia. More recently, Laura lived in Chile for 8 years and moved back to Canada in February 2020. Her experience is in operational excellence, lean management, integrated operations, innovation, technology, and circular economy strategies. In 2003, Laura started a consulting company called Flow Partners, which was recently acquired by BBA. Laura is now a partner at BBA, the Director of Digital Transformation, and is also leading BBA's expansion into Latin America from our new office in Santiago. Laura has been very active with the CIM, having served as president of the Montreal branch and on its board of directors in the early 2000s, and was also on the CIM Council for several years. Our second panelist is Daniel Janusauskas. So Dan is he also goes by the name Dan J, and that's for those of us that cannot produce names with 3 A's, 3 S's, and 2 U's. Dan was also born and raised in Montreal and graduated from McGill Mining Engineering in 2012. Dan also has a BBA connection, having worked for BBA for the first 3 years of his career following a co-op work term he did with them. In 2015, Dan wanted a new challenge and joined Detour Gold, where he spent 4 years splitting his time between the corporate office and fly in, fly out at the Detour Gold Mine in his role as strategic mine planner. Dan was also living in Toronto during this period while his wife was completing her medical residency at the U of T. In 2019, Dan took on another challenge when he joined Baffinland Iron Mines as their technical services superintendent. In this role, Dan manages a team of 25 mining engineers, geologists, and mining technicians, and is still working fly in, fly out rotations. Also of note, Dan recently moved back to Montreal. Mitch Regenstreif. Mitch is also born and raised in Montreal and graduated from McGill Mining Engineering in 2012. There's once again a BBA connection, as Mitch did a 4-month work term at BBA in 2011. Upon graduation, Mitch moved to Australia and worked for Rio Tinto at their Weipa bauxite mine for 2.5 years. Mitch moved back to Montreal in 2015 and did an MBA at Concordia University. During his brief return to Montreal from 2015 to 18, aside from working on his MBA, Mitch worked at the Sentient Group, where he worked on mining project evaluations and financial modeling, as well as at FedNav, a maritime shipping company whose majority of business is derived from the mining sector. In 2018, Mitch took on a new challenge and moved to the great mining hub of San Francisco. He initially worked for a small startup and in 2019 joined Shell. Mitch's role with Shell is not related to the oil sands, as you might have first thought. His role has focused around supporting the digital transformation and decarbonization of the mining industry as part of a joint initiative between Shell and IBM. An interesting connection I have with Mitch is that we both went to the same high school in Ville-Saint-Laurent. I'm almost certain we're the only mining engineers to come from Herzliya High School, but if you've heard of any others, please let us know. Our next panelist is Colleen Roche. Colleen is originally from the town of Logie Bay in Newfoundland and Labrador. Colleen came to Montreal to study mining engineering at McGill and graduated in 2000. During her early career, Colleen worked with the Geological Survey of Ireland and did geotechnical consulting in Newfoundland. She then moved to Yellowknife and worked in the diamond industry until 2006. After completing a master's degree in engineering at UBC with a focus on sustainable placement of tailings, Colleen then joined Capstone Mining in 2007, a Vancouver-based copper mining company, where she helped with the construction of the Minto mine in Yukon, eventually rising up to the position of general manager. Colleen currently works at the Pinto Valley open pit mine, also owned by Capstone, just outside Phoenix, Arizona, where she manages a department responsible for health, safety, and environment, tailings, heap leach capital projects, and several other support functions. She's been in Arizona since 2015. Colleen is active in her local community supporting STEM events, which is science, technology, engineering, and mathematics for kids, and mentoring young women in engineering. And by the way, Colleen does not have a BBA connection. Mustafa Kumral, our final panelist, he's been speaking to you tonight as well already. Professor Kumral obtained his PhD from the Department of Mining and Mineral Engineering at the University of Leeds in the United Kingdom in 2000. His research focuses on mineral economics, mine optimization, and reliability and maintenance analysis. He has held many research grants individually and in collaboration with other researchers. Over the years, Dr. Kumral has published over 100 papers in peer-reviewed journals and conference proceedings. He's also supervised over 20 master's and PhD students. He has taught several courses focusing on mineral economics, surface mining, and mining reliability. Professor Kumral has been an associate professor of mining engineering at McGill since 2012. But enough from me, let's hear from our panelists. I'll be directing questions at each of the panelists, but I'll let the other ones know. Feel free to jump in if you have any follow-ups to the responses I've provided. I'm also going to, I'd like to only have the cameras of the panelists. So I'm just going to make sure the other cameras, most of them seem to be turned off already. Just scrolling down the list. I think we're pretty good here. If I switch to speaker view, just got Vincent's camera. I'm gonna shut off. Oh, it's off. Okay. Oh, I don't know why. Okay, we're good. Okay, so let's get started. So our discussion topics are the future of mining engineering, sustainability, innovation, and critical minerals. So let's start the discussion around innovation. We'll start with Laura. Laura, since you've got lots of experience in this field, can you give us your definition of innovation and how it applies to the mining industry? And perhaps you can touch on mining 4.0 as well.
Okay, well, thank you, Jeff. So I'm sure you can find many definitions of innovation out there. There is something for everyone. It depends what you're looking for. For me personally, innovation is fundamentally about problem solving. So it may not sound very sexy, but that's really where the rubber meets the road. And so there's really incremental innovation and breakthrough innovation. Incremental is where we apply critical thinking to close the gap between a current state and a desired future state in a situation where a process or a system is performing below a standard. Breakthrough innovation is where we seek to reach the next level of performance, which is way above the current standard, but we don't really know how to get there. So in either case, we apply problem-solving techniques to close that gap. So I know that in the past, there's been a lot of hype around innovation in our industry. Personally, in my experience, understanding deeply about the problem to be solved is the basic starting point. We don't spend enough time on problem definition. We always chase the shiny object instead, but my advice is to go back to basics. And that also applies to mining 4.0 as well.
Thank you very much, Laura. The next question will be for Mitch. The mining industry has often been perceived as being slow regarding innovation and technology. However, recently there seems to have been an upswing in technological advancements in the industry. What do you think has changed to force mining companies to be more innovative to help make their operations more sustainable and operationally efficient?
Sure, thanks, Jeff. So I think for starters, I mean, on the operational efficiency side of things, obviously there has been a lot of price volatility. I mean, there traditionally that is something very frequent within mining, but there's just been such an enormous amount of data being collected in a lot of the new equipment that's being implemented. If you just think a single Cat truck can produce easily like a terabyte of data a day, and just that data hasn't been taken advantage of for so long. So there's been a large trend to what can we do with all of this information that's being accrued to actually remain competitive, regardless of where we are within, you know, these up cycles and down cycles as well within the mining industry, while also combating challenges that maybe didn't exist previously, like getting people to site, for example. You know, there not as many people might be willing to drive trucks in the middle of nowhere. So then in Australia, for example, a lot more so of a trend towards remote operations and autonomous haul trucks, which is obviously trickling down to other locations as well. Versus on the sustainability front, there's obviously the investor pressure side of things as well, where pretty much every single one of the majors have put sustainability targets for themselves, emission targets to, you know, whether it's reducing by 20%, 30% or so by 2030, then, you know, complete net neutrality by 2050 as well. So even using a lot of these different digital innovations or even physical innovations can actually help in also achieving some of their emission reductions. Like one of our partners helps reduce or has achieved as much as a 10% reduction in emissions by reducing their fuel consumption for their mobile fleet. And none of that was actually swapping fuel types or doing anything crazy on hardware. That was a full-fledged digital solution. So it's helping reduce costs while also improving their overall efficiency and reducing their overall emissions as well.
Excellent, thank you. Dan, you're up next. What investments and operational steps are companies taking to get ready for automation and greenhouse gas reduction options, such as trolley assist, battery electric vehicles, and other solutions?
Yeah, so good question. I mean, there's no doubt that mining companies exist to make money and extract resources, you know, but there's increasing pressure to do it in a sustainable way, both environmentally, socially, and then obviously economically with carbon taxes. So there's a lot of different technologies and investments that are currently being pursued. You've got a big range of options. You've got things that are more akin to the traditional offsetting. You've got you know, wind turbines being installed at mines like Raglan and being investigated at a bunch of sites that aren't able to connect up to electric grids. You've got the partnerships that are being put in place by some of the majors between CAT and Rio Tinto with a zero emissions truck, battery powered truck options. A lot of the clean or sort of future tech companies, mining companies, are also making similar claims that they want to push for trolley assist and battery vehicles. So you've got everything sort of lining up that companies are moving in that direction, that they want to pair both their extraction with the desire to make things better, both operationally and productivity wise, and then also from an emissions perspective. So like, for example, trolley assist systems, it's a very complicated sort of solution that's been around for a very long time, but it's only finally sort of getting a second look at it. It hasn't really been pushed very much in the mining industry recently. It wasn't since the 80s that they had some diesel fuel crises and prices really spiked up, that you got a lot of interest, and now you're seeing that resurgence in that sort of field. So I think you'll see a lot of new technologies that come out along those lines. A lot of open pit mines and underground mines, they haul things uphill for great distances with some very heavy loads. So anything that we can do to take that away from diesel engines and put it onto electric solutions, that'll be a positive. And then you've got other operations like the one that I work at, so Baffinland, we're mining on a mountain. So the battery trucks make a lot of sense, because I can capture all of the energy that I'm losing in terms of potential energy going downhill, put that in the battery, and then use that on the way up when my load is when I've dumped the load off. So there's really no one solution for the different companies and the different sites, because every site is different in terms of remoteness and electrical availability, labor, etc. But I think the one thing that's sort of going to be common among all of those is the need for the infrastructure that lets us establish these technologies, whether it's autonomy or trolley assist, etc. We need to have the roads be in the right conditions, to maintain connections on trolley assist systems, or for autonomous purposes as well. You've got a very defined path, and you need to have things planned out well in advance to make sure you can use those efficiently. Same thing, I think Mitch sort of touched on it. There's a tremendous amount of data that's captured by all of the equipment and systems in mines.
I think Dan froze.
But really, to analyze and gain value, I think there's a lot more to go there.
Excellent, thank you. Next question for Professor Kumral. With the advent of innovation and eventually artificial intelligence making its way into the mining industry, should we be worried that mining engineering jobs will become obsolete? For example, we may get to the point one day where we load a geological database into a computer. The computer determines the mine plan, which is uploaded to the equipment fleet, who then carry it out autonomously.
Yeah, it's a very good question. Thank you, Jeff. I don't think mining engineers will disappear. The industry still need people, because basically artificial intelligence is a group of mathematical and statistical technique. And they are very helpful, in many applications. And I can mention, for example, anomaly, fault detection, prognostic, discovery of latent variable, determination of structural relation associations, hierarchy formation. So there are many applications, but at the end, the human is in the center of all applications. Do you think we are able to develop a kind of robots or autonomous system that can make a judgment, or they have personality, interpretations, experience, risk perception? We make a lot of decisions, but the human decision makings, that we have our interpretation. We are not a machine, and still in mining industry, experience and judgment, personal judgments are very important. Because one important aspect, artificial intelligence is useful if you have a data. In mining, I mean, the data is expensive. Typically, I mean, in our area, data come from drill hole. Drill hole, it's an expensive process, and we usually make our decision with sparse data, and also our data is not really reliable. I mean, there are always some assaying error, sampling error, and using this erroneous and limited data, we try to make decisions. But artificial intelligence techniques, especially data analytic techniques, I mean, they are useful, especially if you have a significant amount of data, then you can extract information. This is the one topics. The other issue in mining, I mean, in our decision-making problem, in addition to technical uncertainties, we have uncertainties associated with future. And do you think do we have any mathematical technique that can predict the future? I mean, for price forecasting, for example, future unpredictable, you know. I mean, we usually use the historical data and we assume that history will be replicated and we try to predict, but I don't think I don't think any method that can predict future precisely, maybe weekly or monthly prediction, you can make it, but nobody knows what's going to happen in 10, 20 years time. And I mean, as I mentioned, especially I would like to emphasize, one day, if robots can manage some human aspect like cognition, reasoning, comprehension, imaginations, you know, and maybe one day it can be replaceable, but I don't think it will be in near future, you know. I don't think our generation cannot see this development. We still will be in the center of the mining industry, I believe.
Good to hear. Thank you. Okay, before we move on to the next theme of our discussion, I just want to let the audience know that the CIM is hosting a virtual symposium, which is going to be held November 1st to 3rd, called Mining 4.0, the Digital Mine. The symposium will focus on the latest state-of-the-art developments and technologies in the mining and minerals industry. And registration before October 13th, there's early bird rates. I actually just saw an email come through about an hour ago, the invitation for this event. Also, before we move on to the next theme, I just want to remind the audience, if you want, you can post questions in the chat. I don't see any questions, which means you guys are all attentively listening to the ongoing discussion. So that's great. So let's dive into the next topic, which is sustainability. Of course, one of the hot topics related to sustainability is climate change and decarbonization. Over the last few years, and I think Mitch mentioned this earlier, many mining companies have released plans for tremendous greenhouse gas emission reductions, such as Teck and Glencore, who have announced a goal of carbon neutrality by 2050. Vale announced a $2 billion investment to reduce 33% of the company's carbon emissions by 2030. And it seems that every week a new company is coming out with such announcements. This week was IAMGOLD. They also came out with a decarbonization announcement. So we'll bring Colleen into the mix here. We haven't heard from Colleen yet tonight. So Colleen, you've been involved in sustainability for a good part of your career. As I did earlier with Laura, when we opened the discussion on innovation, can you give us your definition of sustainability as it relates to the mining industry?
Well, that's a big one. Hi, everybody. So I'll keep it short and philosophical. I think that the definition of sustainability as it applies to mining is tricky, right? Because we're a non-renewable resource. But I think that the way that mining can be sustainable is to have a positive impact on the world and the communities where we work. So what that means more practically, I think, is having safe operations, minimizing environmental impacts, which, like you said, all the majors are making those commitments now, which is nice to see in mining where we have a pretty negative legacy. You know, we still have in the United States where I am Superfund sites and legacy mines in Canada from generations gone by that I think impact our reputation, but it's great to see now that mining is actually going the other way and trying to be a leader in these areas. So I think that's the pathway to mining being sustainable. And finally, I think it's the community impacts too. It's building communities, it's generating training opportunities, education, and building wealth and positive impacts into the communities where we work. But I'd love to hear anyone else's take on that too.
That's great. I need to flick a light switch. Give me 5 seconds. All right, it's getting dark here in the West Island. Okay, thanks, Colleen. Mitch, What pathways are mining companies leveraging to meet climate targets they have set for themselves?
Sure. So I think, I mean, even what Laura had mentioned before around innovation of just the first step is understanding the problem in greater detail. That applies to sustainability as well. So some companies are better at that. So I mean, just calling out Rio Tinto here, just where Angelina actually currently is working for, but they've done a great job on that as well in terms of just really doing that analysis, understanding even which commodities, which mines, which facilities. So they know, I mean, a third or more of their emissions are from their aluminum sector, exactly how much are from, let's say, like the cathodes from the actual aluminum smelting process versus from the mines and the actual mobile trucks as well. So that first step is, you know, where are the emissions on top of just how much do we have? If possible, trying to get to also more granular and real-time analysis of that too. So not just a once a year sustainability report where understanding the repercussions of what you're doing is just going to be so delayed that it's like, is it even really as connected as it once was? But then there's kind of those two main facets. So there's, let's say, the fixed assets, obviously. So I'll even bucket smelters and refineries into the mix there as well. So a growing trend towards renewable energy for places unlike BC or Quebec that don't necessarily have hydro power or clean energy at their disposal. So there is a growing shift, especially like Chile is another like a big region where a lot of the major mines are going towards like full renewability. If not, they're kind of like at least like 50% there as well. But then also carbon capture is another area that's also really interesting that we're looking at, you know, for a lot of these smelters, which are heavy emitters, where there's kind of that major smokestack, how can we capture that and then either store or utilize that CO2 if there is the nearby opportunities available. But then also even alternative feedstocks. So coal is obviously not ideal in our current world. Also, can you guys hear me just because everyone is frozen?
Yeah, we do.
Okay, cool. So everyone's face is frozen, so just checking. So yeah, alternative feedstocks for, let's say, a lot of these smelters where coal is still required for steel, lead, zinc, whatever the case might be. So how can we even look at completely replacing some of those? So the renewable will take care of, you know, the power sources, your scope 2 emissions, but then using, let's say, even hydrogen potentially as an alternative feedstock, as well as even biochar. So waste from the agricultural industry that can be actually potentially used as an alternative kind of coking option. Then just last point for the mobile side, obviously there's the alternative fuels. So a lot of these majors like BHP and Rio are looking into biofuels right now because that could actually help reduce their emissions by, like, let's say up to around 70% in the near term. So it's not perfect. They're still burning something. You're using, you know, agricultural products, but at least something to act as a transition. And then from there, there's a lot of testing right now going on in terms of hydrogen. You know, what can that look like? Some testing going on currently with hydrogen trucks as well. But then also even the charge on challenge. And for those who don't know, that's a challenge where all of, let's say, the big players within the mining industry globally came together and put a challenge out to the world saying, how can we electrify our fleet? Because we don't have the expertise, and albeit there's been some more recent announcements from Komatsu and Caterpillar in relationships and partnerships with companies, that might not be enough. So they put a challenge out where dozens and dozens of companies have essentially put forward proposals to try to essentially address this challenge firsthand for open pit operations to completely replace fossil fuels and to move to a fully electrified mobile fleet as well.
Excellent answer. Thank you. Colleen, back to you. What is the role of mining in decarbonization of the economy?
I feel like I'm the panelist least qualified to answer this question, but I'll give it a shot. I think the obvious one, and I work in the copper industry, so I recently heard in the news that there was a UN resolution at this latest summit for all people to have access to electricity by 2030. It's hard to believe that there are still parts of the world that don't have the benefit of electrification, but obviously that those types of infrastructure are still being built, and there's going to be more reliance on them in the future as we electrify and decarbonize the economy. So copper has a huge role to play in that, obviously. But I think what's overlooked, and maybe someone on the panel can comment or elsewhere, is the infrastructure that we're going to need to build to make this transition to a decarbonized economy. I don't know exactly what that entails. It looks different in every corner of the world, but it's going to be huge. Here in the United States, there's a multi-trillion-dollar bill about to be passed to try to make a start on the infrastructure that we're going to need. And all of that relies on the raw materials that our industry brings forward.
Especially some of the critical minerals that we are going to talk about in a few minutes here. Thank you, Colleen. A last question on sustainability goes to Laura. Laura, where do you see sustainability and digital transformation intersecting?
Well, I believe there's a strong connection between the two objectives. So digital technologies are by default an enabler for continuous improvement because they provide the data that we need for effective decision-making. Sustainability in and of itself is actually a transformational journey, and it requires information to understand the current situation and then improve on it. So we know we cannot improve what we cannot measure, and therefore we need data for analysis and understanding. So digitization provides that opportunity, so a very strong connection. An obvious example is decarbonization, as was just being talked about, the need to measure scope 1, 2, and 3 emissions along the value chain. That's very complex with many ramifications, requires the application of digital to measure, analyze, report, and improve. Not only report, but obviously we want to improve, right? So at BBA, we're exploring this intersection between sustainability and digital in practical terms. And I really think, we need to leverage digital technologies to model production systems, value chains, and their complexity, and then, apply different techniques, artificial intelligence or otherwise data science to mine the data, to target improvements where they are the most impactful, because really what we want to do is move the needle to become more sustainable. So the two things are very related. And we need to continue to work along those lines.
Thank you. I have a question in the chat here from Stéphane Pelletier. I like it, so I'm going to throw it out there to anyone who wants to answer it. He says, do you think that the 2050 negative greenhouse gas announcement is more of a publicity stunt, as most operating mines will be at the end of their life cycle and only push back that announcement for the next generation of mining?
I can jump in here. At the end of the day, I mean, I don't think those mines that are closing in the next 5 years are going to be doing a whole lot realistically, especially when a lot of those emission targets are initially for 2030 and then for 2040 or 2050 as well. But that being said, we are speaking with a lot of these companies and trying to understand what can be done. And a lot of them are extremely serious about the ambitions. And some realize that, okay, yes, we can make some of these initiatives NPV positive and actually reduce our emissions profitably. Others will be less so. But that's obviously depending on which company you're talking about and which ones are more responsible than the others as well. But that being said, some are much further along in their journey as well. So, I mean, as Jeff mentioned before, some companies, I think you said IAMGOLD just announced this week new targets. I can't speak to how they're doing generally in terms of understanding where their emissions are coming from, but there are definitely the leaders in the industry like a Rio Tinto versus some of the other ones that are still kind of in the infancy and just understanding what are the emissions, where are the emissions, and what can actually be done. But that being said, because of that investor pressure, there is a lot of conversations are happening essentially right now to understand how to reduce those emissions in a serious manner.
That's great, thanks. Okay, we'll move on to the next little segment here is more focused on students and education. So first question to Professor Kumral, how does mining engineering education integrate with sustainability and innovative technologies?
Yeah. Thank you, Jeff. I mean, as I mentioned before, artificial intelligence is one buzzword that we need to seriously consider to integrate our curriculums. The other aspect is sustainability. But the issue how we are gonna incorporate these topics into our curriculums. I mean, one way to add a new courses into curriculum, which is not very easy for us because, as you know, we are getting background in rock mechanics, we know ventilation, and suddenly, and we face with the high level math and statistics, and it is not easy. I think it's the best way for us to develop a 500 level elective type of course initially, then over time to integrate, because it takes for us time also. I mean, artificial intelligence is not easy. It's a huge area. There's plenty of different techniques. Sustainability may be even more difficult. I mean, sustainability shouldn't be understood just an environmentalism. You know, there are is a very broad term. It includes the community, indigenous communities, safety, supply chain security, cultural heritage, transparency, corruptions, mechanism design, conflict resolution. Those are very different topics for us, you know, and then we need to digest. And we're not, I mean, we highly, I mean, we are going to learn more and more social science. I mean, we need to learn. I also mentioned in the class to new students, you know, you need to learn more sociology, psychology, and because social risk is the one of the main aspect in mining now, and we have challenges. The other important challenge in terms of curriculums, and we have I mean, artificial intelligence, not only in engineering, it's also in education, in education technologies. There's a lot of, and we are living a kind of information age, and there's a significant knowledge accumulation. And every year, personally myself, I feel that I need to renew myself. And every single year, I need to modify my lecture notes. I mean, I found topics is getting old. I mean, everything changing so fast, adding I mean, rather than adding new courses, maybe modifying courses is another challenge us. But of course, at the end, these two topics, artificial intelligence, I mean, the robotics, automation, data analytics, and sustainability should be to our targets to consider or add into our curriculum soon.
Excellent, thank you. Laura, how can new mining engineering graduates prepare for the challenges industry is facing now and tomorrow?
$1 million question, right? I think Professor Kumral already talked about a lot of the areas that you know, we need to be aware of. And also, you know, new graduates now, by definition, they're digital natives. So I don't think I need to address the need and importance of staying abreast of, you know, technology innovation in our industry. I think that's in the blood of this young generation. But what I would say is I would encourage you to look beyond the industry and learn from other sectors. Early in my career, I had the opportunity to work in automotive and aerospace industry. And it was just an invaluable experience, which I brought back to the world of mining and applied in different ways. So it is very healthy to take a look outside, but please do come back because we need you to change our own industry. Another aspect maybe that I would just like to mention is to inform yourselves on the issues related to obviously sustainability, ESG, but also the 17 Sustainable Development Goals of the United Nations. And what I mean by that is don't just, you know, take what you read in the press, but do try to go deeper in your thinking and critical thinking. Challenge, you know, what you read and ask yourself, what can I do to help my industry move in this direction, right? What skills do I need? What experiences should I be seeking? And also find mentors within and without your industry to help guide your choices and kind of put together a vision for yourself that makes sense for you in addressing, you know, being part of this industry with many challenges still.
Excellent, thank you. I know we're going to lose Mitch in 4 minutes here, so just want to take this opportunity to thank Mitch for joining us and your wonderful insight. The next question for Colleen. Colleen, in your opinion, what can the mining industry do to make mining careers attractive to the next generation of engineers?
Well, it's got a lot of overlap with Laura and Professor Kumral's answers that they just shared with us. But what I would add to that is we need to promote our use of technology, the things Mitch was talking about, the data harvesting that we're doing to try to enhance our preventative maintenance is, you know, super cool, I think. And being 20 years out of school, I'm just amazed by it. And I think we've got to promote how well we're embedding technology to make mining attractive, because it has that reputation for being a little bit behind the times. The other source that I've noticed working in operations for most of my career is that there's an untapped pool of people who get into mining because their families are in mining or they live in mining communities, and getting them into work and then helping them as mining companies to go after mining engineering degrees and to enhance their careers by going back to school. I know within Capstone, we're supporting a number of people right now to do that. And it's really exciting and it's really gratifying being in this industry to see people from mining communities who have that history in the industry to go on to become leaders in mining. And mining engineering is a pretty well-worn path to those leadership jobs. So I think that's a bit of an untapped pool that we need to tap into as well.
Excellent, thank you. Our final topic, we're getting close to the end here. Our final topic is critical minerals. So many of you are wondering what are critical minerals. So in case you're not aware, in 2020, the Quebec government published a document outlining its plan for the development of critical strategic minerals. The document defines critical minerals as minerals that have economic importance in key sectors of today's economy, present a high supply risk, and have no commercially available substitutes. They list 22 critical minerals, which are broken out into 3 categories. I did want to talk a little bit more, but I don't want to eat up too much of the time, but I'll just list off those 22 minerals. It's antimony, bismuth, cadmium, cesium, copper, tin, gallium, indium, tellurium, zinc, cobalt, rare earth elements, platinum group elements, graphite, lithium, nickel, as well as magnesium, niobium, scandium, tantalum, titanium, vanadium. Document is very easy to find on the internet. Just Google Quebec critical minerals and you'll find this fantastic document. So in our last couple of minutes here, I'll throw the first question to Dan because we haven't heard from you for a bit. So Dan, with demand for critical minerals increasing, how does the mining industry balance the need for these minerals and the greenhouse gas emissions related to mining and the potential impacts on climate change?
I think we've touched on most of that already with all the innovation and the sort of modernization of the mining industry. So that goes a long way towards balancing those needs. But mining exists to make our modern lives possible. Without these minerals, we wouldn't be able to have the electric cars and all these other things that we're pushing towards nowadays. So you've got a lot of mining operations that are reevaluating what they've got. Some of these things that are now seen as important and are being sort of, that are the buzzwords in today's industry. It's coming more to the forefront, and you've got some operations trying to see if they can make byproducts or manage to extract this as part of their main operations. So I think that's a pretty easy way to get started. I think Laura mentioned the need to understand the greenhouse gas chain throughout the different time horizons and how you look at things. I think that's another thing. It's not so much on the mining industry to do it, but society in general. Hopefully there'll be some consolidation around one or a couple technologies in the future, because right now it seems like it's more of a shotgun spray of technologies that are being implemented and pushed. And do we really understand how each one of those things actually impacts us in terms of emissions? I doubt that's the case, and I think that's something that the mining industry and society in general needs to get a better handle on.
Excellent, thank you so much, Dan. I think that answer actually wrapped up and summarized, like you said, a lot of the things we've spoken about. So we're right out of time. It's 7:01. So before I hand it back to Professor Kumral, I want to thank the panelists. Very, very interesting answers. A lot of good discussion. I'll also remind everyone that we've recorded and we are still recording this event. So I think there'll be a link that'll be sent out for people that missed the beginning or missed certain parts of it. So thank you very much, and I'll pass it back to Professor Kumral.
Yeah, thank you very much, Jeff. And I think this is the end of our event.